Deburring sharp edges inside cylinder head ports is a crucial step in engine optimization. These sharp edges can create unwanted turbulence, disrupting the smooth flow of air and fuel into the combustion chamber. By carefully smoothing and rounding these surfaces, airflow becomes more streamlined, which enhances combustion efficiency. This process not only helps to maximize engine performance, but can also contribute to improved fuel economy and reduced emissions. Ridges and seams inside cylinder head ports often originate from a variety of sources during the manufacturing process. Casting imperfections are a primary cause, as molten metal can leave behind uneven surfaces, lines, or excess material when it solidifies. Additionally, artifacts from machining, such as tool marks or leftover flash, can contribute to irregularities within the ports. These imperfections can disrupt airflow, potentially affecting engine performance. Understanding where these ridges and seams come from is essential for diagnosing and improving port quality. Sharp edges and seams on surfaces can significantly disrupt the smooth flow of air. When airflow encounters these irregularities, it becomes turbulent, causing unpredictable patterns and increased resistance. This turbulence interferes with the efficient mixing of air and fuel, which is essential for optimal combustion. As a result, the combustion process becomes less efficient, potentially reducing performance and increasing emissions. Minimizing sharp edges and seams is therefore crucial for maintaining streamlined airflow and achieving better combustion outcomes. Deburring is a crucial step in achieving smooth, precise finishes on metal components. Among the tools commonly used, the fine double-cut burr stands out for its effectiveness in precision work. This specialized burr features two sets of cutting edges, allowing for efficient material removal while minimizing vibration and chatter. Its design enables greater control, making it ideal for detailed tasks where accuracy is paramount. By choosing the fine double-cut burr, professionals can ensure cleaner edges and a higher quality result in their projects. Begin by thoroughly cleaning the cylinder head port to remove any dirt, grease, or debris that could interfere with the deburring process. Use a suitable solvent and brushes to ensure all surfaces are free from contaminants. Once the port is clean, inspect it for any remaining particles or buildup. Next, securely position the cylinder head on a stable workbench or fixture, making sure it cannot shift during the procedure. Properly securing the workpiece is essential for both safety and achieving precise results during deburring. Using a fine double-cut burr requires precision and control to effectively remove ridges and seams. The burr should be guided gently along the surface, applying minimal pressure to avoid gouging or damaging the port. It's important to maintain a consistent angle and steady motion, ensuring that only the unwanted material is removed. By working slowly and carefully, the port surface remains smooth and intact, preserving its structural integrity. This technique helps achieve a clean finish without compromising the quality of the port. Maintaining consistent pressure and angle is essential for achieving a smooth, uniform finish throughout the port. Begin by establishing a comfortable grip and steady hand position, ensuring that your movements remain controlled. Apply even pressure as you work, avoiding sudden changes that could create uneven surfaces. Regularly check your progress and adjust your angle as needed to follow the contours of the port. By focusing on these techniques, you can minimize imperfections and produce a professional quality result. After completing your project, it's important to thoroughly inspect your work. Carefully check for any remaining sharp edges, as these can pose safety hazards or affect the performance of your design. Use your hands and visual inspection to identify areas that may require additional smoothing or finishing. Additionally, ensure that all sources of turbulence, such as rough surfaces or protrusions, have been eliminated. This attention to detail helps guarantee both safety and optimal functionality in your finished product. During the deburring process, safety precautions are essential to protect both workers and the workspace. Wearing eye protection helps shield against flying particles and debris that can result from removing burrs. Proper ventilation is equally important, as it prevents the buildup of dust and fumes, ensuring a healthier environment. Additionally, using gloves and appropriate clothing can further reduce the risk of injury. By following these guidelines, the deburring process becomes safer and more efficient. After the deburring process is complete, it is essential to thoroughly clean the cylinder head port to ensure no debris or metal shavings remain. Using compressed air, carefully blow out any particles that may be lodged in crevices or corners. A lint-free cloth or specialized cleaning brush can help remove stubborn residue. This meticulous cleaning step prevents contaminants from entering the engine, which could cause damage or affect performance. Ensuring the port is spotless prepares it for the next stage of assembly or inspection. Deburring plays a crucial role in enhancing airflow within engine components, leading to more efficient combustion and improved overall performance. By removing sharp edges and imperfections, the path for air and fuel becomes smoother, reducing turbulence and increasing power output. These techniques not only contribute to greater reliability, but also help extend the lifespan of the engine. Applying deburring methods ensures that your engine operates at its best, maximizing both efficiency and longevity. Embracing these practices can make a noticeable difference in achieving optimal results.